It should go without saying that one of the most important parts of 3D printing is the material that you're printing in, and nowadays there's so many to choose from. It can get pretty complicated minding your ABSs and PLAs, so keep watching for a handy description of almost anything that you can make a 3D print out of. The main material you'll probably be printing in is plastic filament, but even this one category contains multitudes. All of these filaments are generally used in fused deposition modeling printers, which are the norm for consumer printers, so if you 3D print at all, you're probably at least familiar with these first few filaments I'll be talking about. These two most common filaments are PLA and ABS. PLA stands for polyactic acid, while ABS stands for acrylonitrile butene styrene. PLA is odorless, low warp, and one of the more eco-friendly materials available, as it's made from cornstarch and is biodegradable. ABS is stronger, can withstand higher temperatures, and be post-processed. There are many variations to be found on both of these plastics, with each manufacturer having their own formula that makes their filament stronger or more flexible, glossier, or more matte. One special variation on ABS is HIPS, which stands for high impact polystyrene, and is less likely to warp. A third type of plastic filament is PET, or polyethylene terephthalate. This is the type of plastic used in water or soda bottles, and is clear and odorless. It is stiff and lightweight, but can be brittle. Another fun plastic used in 3D printing is thermoplastic elastomer, or TPE, and what's neat about this one is that it's very flexible and rubbery. Unlike most of these other materials, TPE can bend and stretch without breaking, which makes it very useful. Other plastic filaments you might find are nylon and PVA, polyvinyl acetate. Both of these are very sensitive to moisture. PVA is completely water-soluble and is used mostly for 3D printing supports, as it can be dissolved away after printing. On the other end of the durability spectrum is polycarbonate, which is what they make bulletproof glass out of. It's extremely durable and can even bend without cracking. In addition to plastic filaments, you can also find filaments with bits of other material in them. These filaments are made with around 40% of a material such as wood, metals like bronze, brass, or steel, or even a carbon filament, while the remainder is a binding agent or a type of plastic like PLA or ABS. These work just like regular plastic filaments, but retain some of the properties like the color and texture of the add-in. It's not quite like 3D printing would, but it's pretty close. However, not every printer takes filament. If you're working with a stereolithography printer, the family of materials you'll be using is resin. Resin, and we're talking about just 3D printing relevant resins here, the word covers a lot of materials, are a liquid or epoxy photopolymer. The photo in photopolymer refers to light, and as such, these materials are light sensitive. Specifically, they harden when exposed to UV light. Resins are just as varied as filaments and can harden into polyester, vinyl, polyurethane, and many other things, all of those with different properties, including flexibility or castability. Another 3D printing material, and the one we use over at Kids Creation Station, is sandstone. Sandstone is made up of a fine powder made from a mineral called gypsum. Gypsum is used from everything from plaster and construction to dentistry to treating water for brewing alcohol and mead. The gypsum powder is printed layer by layer, each layer held together by a binding agent and colored with ink if desired. Sandstone prints can look amazing with high resolution detail and full colors, but are fragile compared to the plastics and should be used mainly for decoration. A similar process is used when printing in ceramics, where layers of a fine ceramic powder are bound together by a binder before being fired in a kiln and glazed. Like regular ceramics, this material is heat resistant and food safe. A similar process is also used when 3D printing with paper. Yes, paper, the same thing you 2D print on. Dozens or hundreds or thousands of sheets of paper can be individually cut, inked, and layered in order to make a 3D object. There's also 3D printing wax. The process behind this is similar to FDM printing, but uses two different types of wax at once. The finished product begins as a quick hardening molten wax, and is supported during the build by a second type of wax with a lower melting point. When the print is finished, the second wax is washed away in a heated bath, leaving only the now hardened first wax. Of course, these are just the types of materials that you can find on Shapeways. More industrial 3D printers are using materials made of full-fledged metals like aluminum, steel, or even tungsten. Experiments are even being done with graphene, which is so cool it really deserves a video in its own right. It's pretty much a miracle material that's both super strong and super lightweight. There's also been lots of recent developments with 3D printed food. Right now, the majority of printable foods are chocolate or confectionery, or foods that have to be baked after printing like pancakes or vegetable pies. So we're not 3D printing steak quite yet, but we're on our way. Until then, though, I hope you like quiche. And of course, last but not least, is 3D printing organs. Companies like Organovo have made leaps and bounds in 3D printing replacement body parts and organs for people, including ears, kidneys, livers, and hearts. These materials, which are grown or synthesized from human cell samples, are still highly experimental, and we probably won't be printing these anytime soon, but hopefully within our lifetime, 3D printing will have eliminated the need for organ donors. As you can tell, there are a variety of materials that can be used for 3D printing, each with their own purpose, and this selection will only grow as 3D printing as an industry gets bigger and bigger and is used to solve more and more problems. After all, a printer is only as useful as the things you can print with it. Thanks for watching.